Hello class, welcome to today's lesson. And today, like I told you, we're gonna continue with application problems. Okay, in this case, we're gonna do two problems, these two, that are going to be very similar to the ones appearing on page 162 and 163, which are the ones that we're gonna work today. And they are a little more complex than the ones before, okay? So pay a lot of attention. Okay, so let's start with this problem. Classic problem in mathematics. You know, there's always a problem about two trains separated by a distance, and they're gonna meet one another, and you have to know how much time it takes them to meet. Okay, let's read. It goes like this: two trains, A and B, are separated by a distance of 100 kilometers, and we have a period. And right away, I can already draw my situation. It's always, if you can draw something about your problem, do it. A very simple sketch or a very simple drawing, it's always a good idea. So this is like the road or something. I mean, of course, they're gonna be. Technically speaking, they're gonna be going on different roads, right? You're gonna have train A over here and train B over here, and the length of these two lines, of these two segments, is 100 kilometers, like so. Okay, so that's, I'm representing by this little sketch my first sentence. Then they start traveling towards each other so that they will eventually meet. So train A will go to the right and train B will go to the left. The speed of train A is 22 kilometers per hour, and the speed of train B is 35 kilometers per hour. Okay, in here in my little space for facts or data, I can write that the speed of train A is 22 kilometers per hour, and the speed of train B is 35 kilometers per hour. Perfect. And that's all my context. Okay, then comes the questions. Question A: how much time will it take them to meet? So, as we know, they're going to be traveling in opposite directions, and they're going to eventually meet somewhere. Like, let's suppose they're going to meet at this point, okay, right there. Train A will be here, and train B will be here, and we consider this as meeting, okay, or passing one another, basically. Okay, so how much time is that going to take from the moment they start traveling? And let's assume that they start traveling at the same time. That's a fact I forgot to write in here. That's a very important fact. We have to specify that they start traveling at the same time. So how much time is it going to take them for the trains to meet? That's the question. Okay, so let's solve it. What is the logic behind this problem? If you notice, guys, at this point, let's suppose that they have already traveled and they are already at this point in which they pass one another. And then what I can observe, if I pay attention, is that this is the distance traveled by train A, which I can label as dA, the distance traveled by train A, and all of this is the distance traveled by the train B. And remember, always specify your variables. So I can write here where SA is the speed of train A, SB is the speed of train B, comma, comma, dA is the distance of train A, and dB is the distance traveled of train B. Perfect. So we have this. Okay, and what can you observe, guys? is there a relationship between the distance covered by A, this yellow distance, and this other yellow distance, the distance traveled by B? What would be the sum of this little bit plus this little bit? It's going to be 100 kilometers, right? According to the geometry of my diagram. This plus this has to be 100 kilometers. So that's an equation that I can write right away. I know that the distance traveled by A plus the distance traveled by B has to be equal to 100. Remember, you can always ignore the units right here, and I think that's the best way to do it. Okay, 100 kilometers, perfect. Now, going back to our previous application problems, I showed you that there is an equation in physics which goes like this: the distance equals velocity or speed times the time. And I'm gonna use this formula of physics, each for uh, one for each of my two trains. So I can write this: the distance traveled by the train A is equal to the speed of A times the time. And another equation, similarly, the distance covered by B is equal to the speed of B times the time. So I have three equations: equation 1, equation 2, equation 3. It's always a good idea to label the equations, okay? Always label the equations. When you have equations, label them. Equation 1, equation 2, and equation 3. We continue working on this other part. Okay, now all I need to do, guys, is like before, I need to combine my equations. If I can, I will combine them. That's why we write equations, so that we can play with them and try to see if there's a way to combine them in order to produce more knowledge or more um, a good way to solve my problem. Okay, look, dA is equal to this, so I'm gonna put this in there, and dB is equal to this, so I'm gonna put this in here. So there we go. There you go. This is my equation number 4. It's a very important equation, so I may as well frame it. And it's basically equation 1 converted by the combination of these two other equations, and it gets converted into this. Now, do I know this value, guys? Do I know the speed of the train A and the speed of train B? Yes, we have them right there. So I may as well introduce them or substitute them in here. So we have 22, that's the speed of A, times the time, plus 35, because that's the speed of B, times the time equals 100. And voila! If you notice, we have this equation which only contains one variable, which is the time. So I can solve it. Let's solve it. We have 22t plus 35t. We have 57t equals 100. T equals then 100 over 57. And that's about it. Okay, if we have to, if we want to get the decimal representation of that, this is going to be equal to 1.754 approximately. And this is my solution, guys. This is the time it's going to take both trains to reach this precise point in which they meet one another. So that's right. What is my conclusion? I write conclusion. Well, the conclusion for the exercise A at least, they meet after 1.75 hours. And I'm done with exercise A. Now, exercise B, they ask me at what distance with respect to A will they meet. So this was where A was. Okay, this is the starting point of A. So at what distance from A will they meet? Basically, they're asking me for the distance traveled by A, you see? Because they meet right here, and A was right here at the beginning. So with respect to A, they will meet at this distance, which is dA. How do I find it? Very simply. Look at this equation over here. Look at this equation. Okay, you can find dA as long as you have SA, which you do, 22, and the time, which we already have, which is 1.75 hours. So I'm gonna make a little space over here, and in order to answer B, we write this equation: dA equals SA times T, and then dA equals 22 kilometers times 1.75 hours, and that's it. We calculate this multiplication: 22 times 1.75, and we get 38.5 kilometers. So that's my solution for the exercise B. At what distance with respect to A? They meet at a distance of 38.51 kilometers with respect to A. And that's it, guys. This is my proper solution to the problem. This is what my reader wants to read. Okay, my reader maybe is not interested. I mean, unless your reader is a teacher, I care about this process. Okay, I care about all you do. But you know, like your casual reader only cares about the conclusion, right? If you have a boss, okay, if you're working for somebody, they don't care about this stuff. They care about the results. You see what I mean? So you're gonna give this to your boss, okay? Because they don't really care about this. They care about the conclusions, and you have to frame those conclusions in proper language, in proper normal human language. Okay, so that's the solution to the first exercise. Now let's solve another problem. Problem number 2. It goes like this. We have Fernando and Fernanda are married. We have a couple right here. Fernando's weight is 90 kilograms and Fernanda's is 65 kilograms. They go each other on separate diets to lose weight. Fernando loses 0.21 kilograms per day and Fernanda loses 0.12 kilograms per day. Okay, that is the context. First question, after how many days will their weights be equal? Okay, guys, so let's see. As you can see, Fernando is losing weight faster than Fernanda, and they will eventually reach the same weight because the speeds are different, right? The speeds at which they lose weight are different, and eventually they will reach the same weight. So let's see. For exercise A, what can we do? Okay, look at what I'm gonna do. First, I'm gonna write an expression. I'm gonna writing an expression for the amount. Well, no. Let me do this instead. You know, I'm gonna write an expression or an equation that gives me Fernando's weight after X days. So suppose that they start the diet right now, and then X days are gonna pass, and I wanna write an expression that will tell me the weight of Fernando after X days on the diet. So it's gonna be like this. Fernando's weight after X days will be this: 90, which is his initial weight, minus 0.21 kilograms times the number of days, x. You see, all of this expression is giving me the weight of Fernando after X days, after X days have passed. Okay, if we have 0 days, then all of this is 0 and we have its initial weight, his initial weight. If 1 day goes by, then you substitute 1 in here and we have 90 minus 0.21, and that's going to be the weight after 1 day. You see what I mean? So this is the weight of Fernando after X days. And I'm going to do the same for, well, maybe I should not call, well, no, yeah, I'm not going to write B because that's another question. And I'm going to do the same for Fernanda. Write an expression that gives me Fernanda's weight after X days. Okay, it's going to be very similar. This is Fernanda's initial weight minus the amount of weight she loses per day, which is 0.12 kilograms, times the number of days. So this expression gives me the weight of Fernanda after X days. So this is the weight of Fernando after X days. This is the weight of Fernanda after X days. And now, if look at the question, after how many days will their weights be equal? So I want to know how many X days have to pass until both the weight of Fernando, which is all of this, it's represented by all of this, and the weight of Fernanda, which is equal to all of this, are going to be equal. Okay, so that tells me right away that these two expressions have to be equal, and I need to write down that equation. Okay, I need to know, I need to write this equation like so, because by solving this equation, I'm saying that this is the weight of Fernando, this is of the weight of Fernanda after X days each, and by solving this equation, by solving it, I would be solving, or I would be getting the number of days X at which both weights are equal. So let's solve it. 90 minus 0.21x equals 65 minus 0.12x. Then let's subtract 65 from both sides. We get 25 equals 0.21x. I'm adding also 0.21. Okay, we have this, right? Make sure. And then we have 25 equals this minus this is going to be 0.07 if I'm not mistaken. Yes, no, 0.11. No, what am I doing? It's 0.09. I'm sorry, I'm so bad at arithmetic. 0.09. Yes, this minus this is 0.09x. Okay, perfect. And the rest is easy. We just divide both sides over 0.09, which is equal to x. And finally, x is equal to this division. Let's perform it in the calculator. Wow, that's a lot of days. 277 days. Okay, maybe I exaggerated my numbers over here. So the conclusion is, I think this is gonna be a very unrealistic problem. I did not check whether it made sense or not. So it doesn't matter. Okay, it's just a made up problem. So conclusion, they reach the same weight after 277.7 days. I think they're gonna be very skinny by this time. Let's see. And the other the other question is B. What is this weight at which they become equal? Okay, what is such weight? So let's just input this conclusion after 277 days, 0.7. They're gonna meet each other in terms of their weights, And so I need to put this into any of those equations. Okay, it doesn't matter which one. So let's put it right here. I'm gonna make a division, exercise B. I'm gonna use this expression for the weight of Fernando, 90 minus 0.21 times 277.7 days, and that's gonna be equal to, I think he's gonna get really skinny. Oh my god. Yeah, that's gonna be 31.68 kilograms. Yes, I mean this is this is starving weight. Okay, so conclusion. It doesn't matter, okay? The problem is perfectly okay. I know that this is completely unrealistic, but that's not what we care about, okay? We care about the method and the way of solving it. So the conclusion is they meet at a weight of 31.6 kilograms. Dangerously skinny. Okay, so that's the problem, guys. I did not check. This is what happens when the author of a problem doesn't check whether the problem makes sense in real terms, in real life terms. The problem is perfect. There is nothing wrong about the problem, but we know that, I mean, this is not going to happen in real life. Okay, no one's gonna go on a diet from 90 kilograms, okay, to this many kilograms. That's impossible. That's unhealthy. It's dangerous. It's probably fatal. So just be aware of that. And that happens when the author of a problem doesn't check whether he or she is exaggerating the numbers, etc. But the problem is perfectly okay. Okay, guys. So that's about it. This is how you solve these problems. And now let's go on into solving the problems from page 162 and 163. Thanks so much, and I take your questions. Thank you.